Good afternoon, everyone. Welcome to Barria2 to listen to Ivan Gulenko, who will talk about how to make IT recruiting success. We'll have a talk of about 25-30 minutes, and then we'll be able to share, to ask questions, and have a discussion about what we have heard. So, please.
Cool. So, hi guys. The goal of this talk is essentially to give some of you who are hiring managers a chance to get inspiration how to improve IT recruiting in your company. And for you who are more candidates, maybe job seekers, how to tailor your profile in a way that companies will not overlook you. So let's see. So I'm an engineer, and people ask me why would you do recruiting? Why do you do this job that is often done by people who are non-technical, who just match keywords? And the reason is that there's many things to do just because of that. And there are a couple of companies that are doing already a very good job. Hired and Honeypot are trying to reverse the process, so to make companies apply for engineers. There is Starfighter.io. Essentially, they are teaching engineers how the stock market works and how to write software in this space. It's done by Patrick McKinsey, who is sort of famous on Hacker News. Also, there is Interviewing.io by Eileen Lerner, who is a computer science MIT graduate that has been doing technical recruiting for a couple of years in the Bay Area. And now she has a platform where Bay Area companies are matched with engineers. And it's all about code. So they have sort of a coder pad, and they do algorithmic challenges on data structure. And they've even went so far that they would anonymize the voice. So it's not possible to see if it's a woman or a man interviewing. Also, there's Workshape.io from London. They essentially had the idea, let's ask the engineers what you want to do in your next job. And in this case, somebody said, okay, I want to do front end and UI, UX. And the company says they look for it like UI, UX person, and then there is like a shape, and is matched like over each other, so you can see clearly the interests of the engineer and the interest of the company. So this is how matching is done by Workshape.io, a very cool company. Then there is TripleByte, Silicon Valley-based Y Combinator startup that recruits for other Y Combinator startups. So they essentially tell you, if you interview with us, you will skip all the steps and jump right to the final interview at Dropbox or, Airbnb or whatever. And this is definitely a super attractive offer for engineers, because in my experience as a recruiter, I noticed that after 5 interviews, there's a interview fatigue. So you're like tired. You don't want to interview anymore. So this company gives the value add that you kind of skip steps, which is pretty cool. My motivation is that I believe that hiring is even more important in Europe, because in Europe it's less of a hire and fire mentality like in the US. So here, if you hire somebody, you really stick with the person. And it's the most important aspect, in my opinion, to have cool coworkers, because, no matter how cool the project or product is that you work on, at some point you'll be bored in a way, and the only thing that, in my experience, kept me going as an engineer were the coworkers, my boss, and the people I would spend more time with than with my spouse and stuff like that. So that's something to keep in mind, and I would really urge that you get involved with the recruiting and hiring process in your company. No matter if you're a hiring manager or a candidate, don't let HR screw up the job ads, and take part in the recruiting processes in your company. A Google recruiter once told me that at Google, A players hire A players or A plus players, whereas at normal companies, B players hire B minus or C players. So please, well, don't do that, because I believe it's kind of true at some companies, and I would really like to see that you invest a lot of effort in to get your recruiting processes right. However, I would not recommend to copy the recruiting process of Google and ask to, transfer red-black trees into binary trees where the prime numbers are divisible by 3 or something like that. Because the big companies, they can ask those questions because they have a revolving door of candidates. Because of the big brand, anyway, engineers will come to them and they have like many resumes to look at. So they have kind of a prestige being such a big brand, which your company probably does not have yet. But don't be disappointed, because prestige is just fossilized inspiration. If you do anything well enough, you'll make it prestigious. But up until you are at this point, you have to make your processes in recruiting in a way that are attractive to engineers. So show what you have. You don't have a big brand name, but you maybe have a cool technology stack, great opportunity to contribute. So especially junior engineers will love if you tell them, well, we need an API that does this and that. Please, in this internship in 3 months, you're gonna build this for us. This is, in my experience, the only way to get like Google quality interns in your no-brand company. If you give them like a big chunk to work on. And reply fast to inquiries. So I just talked yesterday to an engineer, and he said, well, he interviewed with like 2 companies, and the second one answered like in 2 minutes, and he stopped sending resumes to others. So as a hiring manager, I would really urge to do this as quick as possible to reply and get back to people. At this conference, I saw one especially good example, Binder. They have 2 posters, and on the right poster, you see exactly their technology stack very clearly, and on the left, you see, do you have what it takes to influence our product? So they communicate, okay, you're gonna have cool technology stack and you can contribute. You don't see anything really about the product and what they're doing, whereas on the other posters, if you go outside, you have lots of more marketing-oriented material, which was clearly not designed for this conference, where this poster is clearly recruiting material. So if you get into the effort to really look at what you want and which kind of engineers you think you want to attract, there is a list of programmer types done by triplebyte.com. This is based on 10,000 matches that they have done. So they matched engineers with companies, and then they looked at what are the differences. And you get some kind of profiles that some of you might recognize yourself in. For instance, there is the academic programmer. So those are candidates who have spent most of their career in academia. Programming is part of their master research. They have very high raw intellect and can use it to solve hard programming problems. So this kind of guys, I usually ask if they can explain what a Git rebase is, to see if they ever have collaborated like with others and not just wrote scripts to, well, bang out some research thingy and then publish the paper. So there's experienced Rusty programmer. So those are candidates who have lots of experience and can talk in depth about different tech stacks, databases, explaining their positive and negatives with detail. When programming during an interview, they're a bit rusty. They usually get to the right place, but it takes a while. So this is a place where probably all of us will end up in, because we are, well, some of us are young programmers, some are older, but at one point we will be there. And I see, especially at smaller and middle-sized companies, a problem to really have people who are like over 50 to keep in the company and like to give them an opportunity to continue growing. But I'll get back to that later. Trial and error programmer. So candidates who write code quickly and cleanly. Their approach seems to involve a lot of trial and error, however. They dive straight into programming and seem a little ad hoc, but their speed enables them to ultimately solve the problems productively. So this might be early stage companies that have no processes in place and they need people to bang out code like really quickly. Practical programmer. Candidates solve practical tasks with ease, even very abstract programs. They aren't comfortable with CS terminology and have a deep understanding of how don't have a deep understanding how computers work. They're not comfortable with stuff like C. So this might be engineers who work like for web agencies. Child prodigy programmer. Candidate is very young, 19 years old, and decided to go straight into work, skipping college. They've been programming since a very young age, and they're very impressive in their ability to solve hard problems. They've also been prolific with side projects and are mature for their age. It's likely they'll found a company in the future. Product programmer. Candidates perform very well on tech interviews will have the respect of other engineers. They're not motivated by solving tech problems, however. They want to think about the product, talk to customers, and have an input into how product decisions are made. So they're like more oriented towards the customer and those UI, UX issues. Technical programmer. Candidates are the inverse of product programmers. They interview well and communicate clearly, but they aren't motivated to think about the UX or product decisions. They want to sink their teeth in hard technical problems. So the thing we saw with Binder is essentially something that is like communicates more to a technical programmer rather than a product-oriented programmer. And those roles that we saw, well, TripleByte in their very, very huge study, I mean 10,000 resumes is really like a lot, they found out that like product programmers, at least in Silicon Valley, they are the, well, companies like them most, whereas the academic programmer is kind of a bit ignored. I'm not sure if this applies completely to Europe, because we are talking here about Bay Area startups, and in Europe, the demand is a bit different. And I'm thinking if it's worth maybe to do a similar study in Europe with companies that are more, let's say, normal. So where to get engineers? So there are a couple of ways. So if you're like a company that doesn't have a big brand name, I'll recommend to have, for instance, a blog about technologies or about the IT in your city. So I, for instance, when I moved to Zurich, the first thing I did, I wrote a blog post about like 8 reasons why I moved to Switzerland to work in IT. And this was like almost 2 years ago. And I still got emails from people who are like, hey, I want to move to Zurich. Introduce me to a great company. So this blog post was the reason why, well, I could start my recruiting company quite quickly. So if you're a company in wherever, I'd recommend to, well, invest into a sort of an online presence about technology. Of course, meetups and attending meetups with a t-shirt with your company or organizing meetups is even better. It's an obvious way to get like people interested in your company and make this sourcing problem easier. So like, I mean, the problem most companies have is they don't have enough applicants. So you have to do as much as you can to solve this. Employee referrals are underrated in my opinion, so companies should pay or incentivize somehow if somebody brings in great people. So this was what Google does. So if you join Google, the first thing they do is like they force you to spam your classmates or stuff like that. At least, yeah, this is what I heard from some people. GitHub is an obvious way also to get engineers. So if you're like using Flask a lot, then it would be great to just look at the profile at the people who contribute there and get them on board. This is a bit the problem of like location. So you can do like queries like this to solve it a little bit. So you can use like the API to query for so in the GET request, I'm not sure if you can see it from the back. It's like API GitHub search uses location Bilbao, language Python, and then you get the engineers who are like in Bilbao that do Python. So, and then don't be evil, don't spam them. Rather look at their blog, and if you send a cold mail, try to make it personalized and interesting for them to read it. So like as a side project, I did it's the result of a hackathon, but we built like a web interface to actually do this. So like you go like, I don't know, JavaScript, like Bilbao, and then you go, yeah, find engineers, and you click, and then you get like what you saw before, but like nicely displayed. And then, yeah, you can, I mean, look up what the people did before and stuff like that. So and that's my side project. I call it gitrecruit.io, and I try to crack the combination between automation and manual work in recruiting. So right now I have lots of manual work in Zurich, and I start to do it in Munich, and we just build more and more tools in Python to automate the scraping of the API and do cool stuff with that, again, without trying to be evil. Yep. So if you contacted the people, it would be great to learn how to reach out. A great example of that, I just looked up on my hard drive and anonymized it quickly. So that's a very, very, very cool company, and they send cold mails. And this cold mail, it's not short, so it's rather long if you look at it. So it's so I'm the co-founder and engineer like you, so you try first line to get in touch and we're the same, so we're not a spammy LinkedIn recruiter who just, spams 10,000 people. But rather you say, why I like you, so you try to make this part personalized. And here it's rather semi-personalized, I would say. It's hey, I came across your website, and based on your experience, I think you could be a great fit for us. So that's a bit lame. When I do these mails, I try to really look at the blog, and if somebody has a blog entry about Lambda expressions in Java 1.8, I try to tell them, okay, look, this company also uses Java 1.8, and also, you care about this, and would be maybe a great fit. So it's a bit less lame. The first line should be somehow, meaningful. And then you tell, what your company does, and what the candidate can do for you. And this mail, this company really, the whole mail is actually pretty good. And they developed it with the CTO, CEO, and showed it to 30 people, A/B tested it, and then they made a student send out those emails to scale it in a way. Yep, that was pretty efficient, I believe. Yep, and then what you do, so you have the candidate, and you probably want to get to know them. So do a phone interview. So in a phone interview, the goal is to really find out if the candidate cannot do anything. So you ask questions that are everybody should be able to answer, like the famous FizzBuzz coding challenge, where you just print the numbers 1 to 100 and divide them by 3, divide them by 5. So easy stuff to get rid of the people who obviously cannot do anything. This would be important and efficient. And then maybe you give a homework assignment, which shouldn't be 10 days, but rather maybe 2 hours or 3 hours. And this you can use to, at the on-site, talk about the homework, and also on top of that, give them maybe small coding assignments that you can do in pair programming to see if the person fits into the company in the way they work. So I generally see the most successful companies in recruiting, they try to spend with the candidate as much time as they can. So as a candidate, what can you do? Obvious way is to have a resume that kind of resonates with the community. So people, however, read resumes on autopilot. It's really, I think the average spent by HR people and even hiring managers is maybe less than a minute. So it would be great to make it really short. So a page per decade, I would say, is something that is reasonable. And contribution is more important than tech and framework. So show how you contributed to the product, to the company, or to the project. It's rather more important than if you use this or that framework. However, there is the problem with HR. So if there is a bigger company and if there is HR involved, you always will get the problem that you have to go through this filter first. And then you have to obviously mention some frameworks such that they forward your CV to hiring managers. The worst case I experienced is when a great engineer doesn't get forwarded to the hiring manager just because the keywords are missing. That's really, really terrible and should not happen at all. Yep. So let's look at a couple of chunks of text, and let's decide together if this is good or bad. So first one would be like, this is like in a resume, the part where you talk about what you did, right? So, designed software application including data modeling, software architecture design, software hardware integration, user interface design, and database management. Created and launched a service that collects product opinions and recommendations from Twitter. The service finds related tweets, removes spam, analyzes sentiment, and creates a structured database of everything that was said about a particular product. The service is exposed as a consumer website and as widgets that can be embedded in online retail websites. Developed, product name, using Python and Django for marketing and allowing end users to experience blah. Evaluated and identified some operation system network stack, performance bottleneck in latency per packet process overhead, and scalability of different network I/O models through various system measurement and profiling techniques. So, which one do you like best? 3, 4? 2?
Basically, depends who's reading this. Because the point 4 is more for the CTO. The second point is more for, I don't know, some business guy or whatever.
Yeah, so gentleman said, so depends who's reading this. So the one is like number 2 is more for CTO and like number 1 is more for business people. Yeah, I mean, that's obviously right. So I would also like prefer 2 the most because you literally can, well, from this sort of short text, you can see what happened and what the person did. And number 4 is my like second favorite. And 1 and 3 is literally like especially 1, I can like, I don't get like, there's no like information in this, so like 0 entropy. I don't know. So I don't get really an understanding what the person did in number 1, right? Although you're right, like if you have the HR filter, then the HR person literally might like 1 more. This is why recruiting is hard, right?
From the
Because
first one, you don't see the business value of it. See that the person did something, they burned some time, but you don't see the result.
so from number 1, you don't see the result and you don't see the business value. I would agree, yes. So it's interesting thing to, I mean, the best thing is just you show to other people, but probably you do this anyway, to other IT people, and then you can improve. So like this might be like totally trivial that I say avoid typos, but there is actually data that supports it like a lot. So this is also a statistic made by Eileen Lerner in her blog about, I think she looked at 8,000 resumes in her career as a tech recruiter, and the frequency of errors and typos was higher correlated with good engineering performance than other factors. And those factors include a bachelor's from Stanford. So that's BS and CS from top school. So the second biggest correlation point was if the person worked at a top company before, like Google, Facebook, or Twitter. So if you want to train for interviews and you want to do a Google-style interview or a company that does Google-style interviews, you just look at cracking the coding interview, interview cake, interviewing IO, so there are like tons and tons of platforms. Depending on, your level right now, I would calculate in like 2 weeks until 2 months that you train every evening in order, well, to perform well. For regular companies, well, learn to communicate what you did exactly, what you're proud of in your project and what you contributed, and ask the companies how they will assess you and prepare accordingly. So like, don't be shy to ask exactly what the company looks for. So, and this is my most, I like this part most. So what many candidates miss is to really interview actually the company back, to really find out if it's a good place to work at. So there are a couple of questions that you probably have heard of. It's called the Joule test. So do you use source control? Can you make a build in 1 step? Do you make daily builds? Do you have a bug database? Do you fix bugs before you write new code? Do you have an up-to-date schedule? Do you have a specification? Do programmers have quiet working conditions? This is what I check if I go to companies to like talk to them about what they need in hiring. So I look at this a lot actually because I see that this is one. I mean, I as a programmer, I want to have a quiet place to work. Do you use the best tools money can buy? Do you have testers? Do new candidates write code during interviews? Do you have hallway usability testing? And those, things you also find on Stack Overflow careers, so they do the same assessment. And questions I would also try to ask is if it's possible to see the source code of the company, which might be able, this would be like something also to show off your code reading skills, right? And also some companies miss to invite you to go with the guys for a beer and stuff like that. So I would try to politely suggest this to get to know the company. So there are bonus questions that are really tricky, and I would ask them if you feel sympathy with the hiring manager and the interviewer. So you can ask, what is the most costly tech decision made earlier on that the company is living on right now? And where do product and feature ideas generally come from? So the first question would be more for the technical programmer, and the second question would be more for somebody who is like a product programmer. I mean, this categorization in the beginning is just like a funny, interesting way to look at engineers. So I kind of like to play with that a bit. Generally, try not to ask like questions that are super uninteresting about like vacation days to the engineers, because their time is valuable, and just ask this to HR, please. Yep. Salary negotiations, probably something that is underestimated and should get more attention if you get a new job. So there's a couple of points that I like to recommend. So don't disclose your current salary if HR asks for it. So because, essentially this can be a benchmark against you, right? And postpone the discussion about money as long as you can, because, it's a benchmark. And if HR insists, then tell them you feel uncomfortable because you want to find out how you can benefit the company, and based on that, you can give a number. So I'm a fan of postponing that as much as possible. And if it's absolutely not possible, which might be the case for bigger companies, then tell them, okay, I want it to not be a benchmark. And hopefully it's fine then. So if you had the luck to get through the whole process, and now this important moment where salary comes, and they suggest you a number, then in my experience, it's a dominant strategy if you try to just be silent. Because the other person, out of social awkwardness, will maybe continue talking. There is a blog post about how somebody made 15K more just by not jumping up and down after getting actually an offer that was on the upper scale of what she expected. So no matter what number you get, it's a business relationship. And in the end, you sell your time and you get the salary. So for them, you're a resource in a way. And 5K more or less for a company that already went through the very painful process interviewing you, in the end, for them, it's absolutely irrelevant. 5K more or less. But for you, it makes the difference in 5 years or 10 years if you can buy a house or not. So for you, it's a big deal, and for them, it's not. So don't feel bad to ask for more. So the last thing I want to start the discussion with is long-term engineering career paths. So the old and rusty programmer, it's a thing that the very senior engineering roles at smaller or middle-sized companies, they don't really exist, and people after 50, they don't really have a way to become better in their career unless they go to management. So this is something that bigger companies really solved, and this is something I tried to do research about. at getrecruit.io, where I try to match companies with candidates. And if you have other ideas on recruiting, just say hi at getrecruit.io. And yeah, that's my ideas about recruiting. So, yeah. So we have a microphone. If you have any ideas that you want to contribute, you can just tell me now, or we can also like chat later. Yeah, over there.
Thank you, Ivan.
Oh.
So we'll have a discussion. If you have something to share or a question.
Hi. In my experience, and maybe this is cultural, if I send an offer to a person without mentioning the salary, I get lots of rejections. So maybe this is a cultural thing, but here in Spain, companies are used to offer crap money. And if you don't start by giving a sensible offer, lots of candidates reject the offer. Have you found this? Or is this something from cultural?
That might be actually cultural. So I operate mainly in the Germanic part of Europe, so German-speaking countries. And I think they might be less willing to discuss salaries and like talk about money compared to other cultures. I mean, at bigger places there is also more like, for instance, Zurich is very small, and the variance and like standard deviation around them. So you have a mean salary and you have like a standard deviation. And in Zurich it's like super high. So for instance, I met senior engineers who make like 130K and like same qualified people who make like 70 at smaller companies because they are like lowballed. And the city is small and therefore you have not like a standard number. In New York or London, you do have that. So there's like less variance, and there it might be more common also to ask for this, because then they want to check if you're like aware of the market or not. Whereas in Zurich or smaller cities, it's like there is no actual number, so it's much more dependent on the company and other factors. But yeah, it's cultural, I believe.
Thanks for your talk. It was quite interesting to see the other side. In particularly, I liked when you mentioned that HR people spend like less than a minute typically on reading a CV.
Oh yeah, maybe like less than 30 seconds.
Maybe less than 30 seconds. So it's
sorry
actually quite a similar case on our side. I guess developers spend like 20 seconds reading the recruitment mails because they all look the same. So then there's obviously a question, who should read those? Because developers don't get money for that, and HR people do. So the next question actually is, if the HR people who do not read the CV carefully and still get money for that, are incapable of getting those keywords out of the CV, is it actually a good sign that they didn't reply to you, which means that it's probably a bad company and you wouldn't probably apply there anyway? Or you think that there could be bad HR people representing actually a good company? With your experience, is there a correlation between quality of reading out the CV and quality of the company?
Probably there is a correlation. I mean, if you're good in one thing, you're good at like other things. So this is actually a live question I'm asking myself, because on the other hand, you have the saying, okay, people who are good at one thing, they are generally good at other things. But then also there is like this halo effect. So you shouldn't judge somebody because he's good at running that he's also good at like, I don't know, like other things. So this is like a research thing I think about a lot actually. So I can't really answer that.
So one thing to see here is that one thing to remember here is that everyone who works for a company has passed through HR first. So the way HR works actually determines who's working for a company. And so if you don't get along with HR, you may not actually fit into that company because everyone else did.
Oh, yeah, but well, I mean, but if a company is small, there is no HR, and HR comes in later. And I have like an example in Zurich, great company. They just hired an internal recruiter, and this guy would turn down, like I recommended them a guy who worked at Mozilla, and like he would turn him down. And I was like rather pissed because like, I mean, this HR guy is like a new hire and I'm very sure that this is a fit. And he's like, oh, whatever, Mozilla. Yeah, so, I mean, HR is definitely, well, anybody who is not able to write or read code is bad at assessing engineers. So what I think, I'm even planning to do like a workshop for HR people to learn about like computer science, JavaScript, Python, and it would be like, I think, a 2 to 3 day course, and it might be successful. Actually, like this kind of training, who would attend this? Like good HR people, right? So I believe you need some kind of training to assess engineers, yeah. And actually, like HR, I mean, in more traditional companies, they think in a way that at other jobs, there's really true that the engineers have to like beg, the candidates have to beg to get the job. But in our domain, engineering, it's the other way around. Like companies have to beg to get engineers. And many HR people don't get this.
Hi. First, thanks for this talk. I'm here.
Hi.
And from my experience, I can confirm that many of the things that you recommended work. I also recommend sending out some test assignments before even looking at CVs. So that's what we do, for instance. Like we receive applications, but we first actually see some work of the person before checking with the CV. But that's not the point I wanted to make. The point I wanted to make is one way to suck at IT recruiting is to be exclusive, to only talk to a certain type of engineer. And I'm, of course, talking about diversity, which is a very broad topic. It's about gender, it's about orientation, it's about being big, small, it's about race, it's about many things. And one of the tricky things about those very successful ways of recruiting for IT is referrals, for instance. So if you get your employees to refer their friends and their former mates, well, they will probably recommend similar people to them, so you will lack in diversity. And also, if you go for beers with candidates, or the guys are going for a beer with candidates, you also like missing out on opportunities to meet informally some candidates from other backgrounds who don't drink alcohol for many reasons. Could be health, could be religion, could be pregnancy or whatever. So do you have any tricks to solve these type of issues? So what we try is to have informal time for meeting candidates during the day where people are coming to the office. So that's the lunch, that's the coffee break, something like this, but maybe you have some other ideas in your experience.
Yeah, so there are like a big tendency towards all you said. So to hire only like, university graduates from the school and be like very in one direction. That's very bad and inefficient. So my dream as a tech recruiter is to help to make the market more efficient. So to make it perfect, so everybody finds a job that he or she likes. And this is a very important aspect you should focus on, and like people who are not fitting your profile in order to look at all available candidates. So I totally support what you just said. Yeah.
Hi, Tom. Thanks again for the talk. It was great. So I have two questions. One is regarding your suggestion that when we get an offer, we should shut up. So does that apply also for emails? I mean, we should wait, or how does it work? Sometimes the offer comes in an email.
What's that? Say again?
So,
the offer comes in an email.
Yeah, so what do we do?
So you don't, I mean, the social, like, you are quiet because you exploit, like, social norms. If you don't reply to an email, I'm not sure if this also applies. You could, for instance, call back. like rather quickly, and say that you are not sure about this and that point if she or he can repeat the aspects of the offer. And then you again have the situation where you can let the other person know that you are like happy but not too happy.
Okay, so in general it's better to negotiate this in person. That's your advice.
Mm-hmm.
Okay.
And I have another thing that I learned doing this business is that if people don't reply your emails, that doesn't mean that they're not interested. So, like it happens so often, I'm hiring also for startups. So there was like one founder that just recently we talked, and he was like, yeah, great, yeah, you're a great recruiter, we want to work with you because you're a software engineer, blah, blah, blah. Send me an email. And then I'll send him an email, hey, it was great chatting to you, it was super cool, I have this and this terms and conditions, let's work together. Silence. Like for a week. So I write again, hey, how are you? I just wanted to ask if you received my email and we can continue further talking about this cooperation that we talked about last week. Silence. And I have one example where I did this for 32 times. And the 33rd time, it was like, hey, Ivan, I'm really sorry that I couldn't answer. I had to launch this rocket ship and stuff like this happened here and there, and I'm so happy that you got back to me. Let's meet for dinner. So it's really important. So like when people tell me I'm not interested, I stop mailing. But you have to keep up the email conversation because people have other things to do and you're like not the most important thing in their lives usually. So this is probably one of the biggest learnings doing this.
Can I?
What's that?
Could you please repeat that speech that I can type as a typical letter reply? I'm launching rocket. Could you please come back to me later?
Yeah.
Hi, so I'm guessing you might be a bit biased, but for somebody seeking a job, would you suggest going through a recruiter if as opposed to job offerings given directly by the companies? And my motivation for that is that so far my experience with recruiters was a bit dreadful. They were very aggressive, and I kind of felt like I'm in a blockbuster for a movie, just with me being the main character. And that kind of felt kind of weird, and I've had much better. Is it okay to perceive the recruiter as the end, as somebody who is working for that company is trying to get my salary lower, as opposed?
Are you talking about like external recruiters, third party?
Yeah, yeah.
Oh yeah. So like I think about to get recruit out of my project name because of this. Because the word recruit or recruiter has such a negative connotation that has a reason. Companies or recruiting companies are usually pretty bad. The whole sphere has a bad connotation because people do keyword matching, not respectful, towards the engineers. So I would suggest working with a recruiter if you like to know the market rates, which companies are good in, let's say, a new city, and like detailed information about the market. Then it could make sense to work with a recruiter. But then again, there is a big variance in quality. So I try to be like on the top level in quality in what I do. So I also don't work like with not so good companies. I only work with companies that I myself as an engineer would work at. So you have to decide for yourself. So if you want to move to another city and you want to know the market rates, it might not hurt to exploit the recruiters to get to know the market rates for salary and stuff. Yeah.
Thank you.
Hello, I just had a question about, as a team, we interview people sometimes, and what are the good coding questions to ask? Well, it's a bit wide, but I read something about classical things like Fibonacci, etc. were not necessarily good, and well, it was quite an open question. But are there some things that you see more pertinent? Well, it's
So how to, like, what are good questions for interviews?
yeah.
So, like, the one part that always works is to ask about projects the person did. So this is even a question, I like the questions most that are not getting easier when you know them. And those are questions like, if you can talk about a project that you did in the past, and if you're familiar with the technology stack, you can like dive deeper, like in an area, and you see how much deep you can go with what you're asking. And this is a way that always works.
Yeah, theoretical questions, maybe not. Then.
Yeah, those Google questions are good for Google and other like companies that can afford to ask them. I mean, yeah.
It's also a good communication opener to open the interview with a question about projects that the interviewee has done before, so they have something to comfortably talk about in a way.
Exactly, yes, absolutely.
Hi, there is a area we not cover here, and I want to ask can you share some tips how to find a good freelancer?
How to find a good freelancer.
He's here.
Wear a T-shirt that says "I'm looking for." No, I don't. I'm not sure. There are different platforms on the internet. I think the most important part is for freelancers to build trust as fast as you can. So, for instance, if I need support with some engineering, I always go like on Upwork or similar platforms, and I look only for people from Ukraine. Because then I can say, hey, I've been born in Kiev, blah, 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 about the thing, like, about our, common heritage. And then there is some sort of trust. And, this is a little thing that I do.
Do we have any other questions?
2, 3. How much time do we have left?
5 minutes.
Okay, so then we make like 1, 2, 3. But the lady was first, actually. I think don't you work for hired.com? Okay.
This is not a pitch for Hired at all. Although I do recommend that you all go to it, but we're only in London, Paris, and Berlin. So if you're not looking to go there, then don't worry about it. My experience mostly comes from the US. I only moved to Europe about a year ago, but I wanted to answer. Sorry, I'll talk louder. I wanted to answer your question about external recruiters. One of the problems with why they're so aggressive and horrible is because most of the time they don't actually get a salary. Their salary comes entirely from commission based on when they place you. So they're going to be as aggressive as they can to get you to accept an offer and to get you to accept an offer with the highest salary you can possibly get, because that increases their livelihood, of course. If they don't make a single placement in a year, they don't make any money that year, which really sucks. I also want to say thank you for the presentation, and that if you all are very interested in the data behind recruiting, he had mentioned Aline Lerner's blog. She is a phenomenal engineer. She has about 10 years of Python data science background, and her blog is all about that in ways, the best practices when it comes to actually sourcing those emails and sourcing from LinkedIn. If you don't want to use any external platforms, it's really fantastic. And my last question to you, sorry, really quickly, was what's the most creative interview process that you've ever seen? Because a lot of the times when a startup does interview, these one-on-one interview processes I've noticed just don't work out quite well. It's very intimidating for the individual, and if you don't know the runtime of a specific algorithm, like you shouldn't have to know that on the spot, whereas some people like Google really do think that that's important. So have you seen any that are particularly outstanding, that really get to the, programming techniques of the startup itself?
So you mean, I'm not sure like about the process, but the way people were hired. So my absolutely favorite story is like a US kid. He's actually on this conference and not in this room. So he was essentially dreaming of becoming a software engineer until he was 12. And he became homeless when he was 14. So like really, really poor growing up in Illinois and really living on the streets until he was 23. And then he started to work as a mechanic, and then looked at in TV that, well, software engineers actually make decent money. And then he found a C++ book in a thrift store for $1.50. And every night after doing his mechanics job, he did this C++ book where everything was like, this code is deprecated, this code is deprecated, because the book was so old. And then he somehow ended up on a conference where he met a German company. And this German company, like 7 months later, they hired him like right away after he had like enough experience in Python and Django. So this is like one of the, this goes back to what you said, like exceptional candidates that are exceptional in their own way, like being homeless and stuff. This experience is like maybe something special. So there are 2 more questions over here in front, right?
Hi, I have 2 questions. First, is the GitHub search available online, or do you have it just locally?
So the API can be crawled.
Oh yeah, but about the website, is it available online, or the hackathon website that you've built, they will not serve?
This one?
Yeah.
No, it's localhost.
Okay. And the second question I have is about actually your website. You mentioned that Git Recruit services and trainings you receive are free, but we take 20% of each revenue that you make with our support. So what does that mean?
Oh, okay. So what I try to build is, so Git Recruit should become a tool to enable us to find engineers. But I want to have like partners in each city that use the Git Recruit tool. So for instance, this tool and other tools we build, like a CRM and a applicants tracking system that you can use for free. So this is what I'm building with a friend. And then the person who does the recruiting in Bilbao, in Milan, in Munich, he gets all this training and the software for free. And then Git Recruit headquarters gets a cut of this. I'm not sure how much the cut is or stuff like that. So this guy already like looked on the website, and this was a very specific answer. So sorry for the rest of you. Is there any questions?
So no more questions? Thank you, Ivan, and thank you, everybody, for your interest.
This package, it shows me everything, it shows me hundreds of packages.
Yes, yeah, they were all empty. I'm going to fetch some for you. Okay. It's hard to turn it on. Okay. Okay. Oh. It's actually asking off. No? Oh, always on. That's fine. Should. Yeah. Okay. Maybe it's the sound is coming, but it's not recording. Okay. You should hear. Cool. Great. No, yeah, that's great. That's fine. Oh, is she the sound technician? I don't see still in the water.
Tony? 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 Hola, hola, hola. I hope some of you are here for IoT and not only beer.
Guess we can start now. Welcome all to How to Make Cerveza with Python. Here I have Cesco Igual. Give him some claps.
Well, thank you for being here. Welcome all. My name is Cesco Igual. I am a backend developer at Elements Interactive. It's a company from the Netherlands. I'm going to talk about how to brew beer with Python, more or less. So there are some things that I would like you to leave this room with some ideas, and some of them are, I would like you to know how to build an IoT backend. Which are the technologies, the protocols, and the tools that are out there, and I will do some comparatives so you get to know what's out there, and also which is the one that may fit you best if you have to do a project like this. Some backend considerations that people will not tell you about, but you as a backend developer, you need to make sure that they are taken into account. You will meet a full running architecture for an IoT backend. And of course, you will learn how to brew beer. Actually, you're not, sorry. If you want to leave the room, you can skip 30 minutes. So first I want to talk to you about Minibrew, which is the project for which we developed this platform. Minibrew is an amazing machine. You can actually brew beer with it, and it will guide you since getting to know new recipes through a mobile app. And then you can choose the recipe you want to brew. It will be sent to your home, and then you will just pour the ingredients into it, and the machine will take care to do everything from the first until the last part of the process. And it will also teach you how to brew beer, even if you have no idea at all. So at the end, you will start having no knowledge about it, and after several brews, you will be a total expert. This machine comes with a mobile app. The mobile app is going to show real-time data of what the machine is doing at this moment. It's going to show what is the current temperature of the ingredients that are inside the machine, what is the current step, what is the target temperature in case you're in a very cold place or very warm place and it takes longer to get to that temperature, etc., etc. It will also help you to see if there is any error in your machine. For instance, it loses connectivity, anything like this. It will also tell you. And it will also allow you to start and stop brewing sessions, so you will actually only interact with the machine through the mobile app. So this is not everything that the project has, of course, because otherwise I wouldn't be here giving a talk. Actually, there is Python in the middle, yes. So, well, not only Python, also some others. I will focus the presentation on actually explaining to you what you have to put in the middle of those two things for it to work seamlessly. So let's get technical. First, I want to share the project requirements that probably when you get a customer or you want to build something like this, you will have. We will need to deliver real-time data. We want to have from the mobile phone, we want to know exactly what the machine is doing in real time or real time. That's fine as well, but quite close. We will need to have security in the communications. We're actually sending sensitive information because the recipes sometimes will be copyrighted, and we cannot let anyone see it. We will need obfuscation because in case somehow the channel got compromised, nobody would be able to see what actually is going through the channel. Authentication, if we get somebody knocking at our API or our platform saying it's a device, is it actually a device? And if one device gets compromised, can we disable it? Two-way communications, of course, because we not only get real-time data from the minibrews, but we will also send actions to the minibrews. So we need both ways communication. Resiliency, the system has to be resistant, and if, in case it falls, it needs to go back fast, because people expect responsiveness in their devices. And also, it has to be lightweight. in the IoT, usually we got, and this is the case as well, we got really constrained environments, and this makes us have to mind every kilobyte that we use in our project, especially in the device. Also, we have to take into account that the packages that we send, information that we send, the bigger it is, the slower it will be. So that's also two considerations on lightweight that we have to take into account. And some other project requirements that we may get is the last known status. What happens if a machine suddenly goes offline? We need to know what it was doing right before. That will help us debug it. Debugging of the machine, of course, for the production personnel, staff. They need to be able to take a mini brew that is not in correct state and be able to debug it, send different channels of communication only for debugging purposes. We will need an admin site also for being able to set up the users, their mini brews, their keys, everything. A mobile app API, I don't need to explain that if there is an app. Rainbows, etc. By this I mean that this is a project that is going on, is growing, so we have to take into consideration that we may get new requirements that we didn't get at the moment that we were delivered the first round of requirements. Actually, this is usually in every project, right? But in this case, as being a startup, it's more likely that this will happen. Then, the other thing that I mentioned before, as a backend developer, you need to take into consideration some things that not always will come as requirements. For instance, you need to take into account scalability, which is a word that is overused. It's in every job offering. It's in every company does a scalability. Every project is scalable. But actually, in IoT, on this project, we have to take it into account when building the architecture. Proven technologies. By this, I mean that we cannot use a technology that is kicking right now and in 1 or 2 years is going to be obsolete. We cannot afford that. Small tech stack. This is important for several reasons. It's going to be easier to maintain for the people that goes after us. It's going to have less errors. The connection tests are going to be easier. We're going to have a much easier life. And error tracking. If there is something going wrong, we want to be able to debug it. This is the usual that we do in Python, but before entering a project, you have to take it into account. Reduce the data transfer. As I mentioned before, reducing data transfer will do two things. One, make faster messages, and the other will make cheaper bills in our cloud provider. And documentation, the most important one, because we all love documentation and we all love to write documentation, so this is something that we have to take into account. Actually, nobody writes documentation. So this is the phase that you may do when you see this list of requirements and you never tackle the project like this. So let's do something, and let's go step by step. Let's go step by step, and let's start with the communications protocol. This is a requirement that this is a decision that depending on how we make it now, it will affect the possibilities that we have later for technologies or software. So we're going to analyze very fast the protocols that are out there. There are some of them that are already out of scope, like we are not even considering them because of throughput, but I will mention them because you could probably build IoT like this, like HTTP, XMPP, DDS, AMQP. MQP is good for servers, but not so much for IoT. Then we got MQTT. MQTT is one of the big players in the protocols for communicating with IoT. It was developed by IBM and then given to the Eclipse Foundation as open source. MQTT is especially tailored for constrained environments and has some good things from AMQP. For instance, has quality of service, where you can decide if you want to deliver the message one, and I don't care what happens, or you want to deliver message one and only one, so you have a range of qualities between that. That's a very nice feature. It also allows routing based on topics, which allows for spreading messages through several receivers. So this is good. There's another one. There's COAP. COAP was developed by the Constrained Resources Group at IETF, and it's also one of the big players in IoT protocol for IoT, obviously. So COAP is slightly different. It uses more client-server configuration, and uses HTTP verbs, even though it's not HTTP, so it doesn't have its disadvantages. Both are targeted for very constrained environments, but even though they are very similar in that, they are very different in some other things. So for instance, they are very different in the way that MQTT uses a broker in the middle, and everyone connects to it as a client. So then you can do PubSub and all of this kind of stuff. And COAP uses a client server both ways. So then that's a big difference already. Another thing is that MQTT uses long-lived TCP connections, while COAP uses UDP. So this is already another big difference. For these reasons, actually probably you could do with both, but for these reasons we chose MQTT. So now that we have our protocol, it's time to look for a solution. So out there you will find a lot of already like companies that they claim that they have a backend ready for IoT, so you don't have to program anything, and that's kind of true, more or less. So we're going to analyze one, because there's not time for analyzing more. I want to analyze one of them, one of these comprehensive backend solutions, and see if it fits our requirements. So I'm going to analyze AWS IoT from Amazon and see if it's actually a good choice for our case. I'm going to go very, very fast through the architecture because Amazon declined to sponsor my talk, so I will go very, very fast. So there's some things that we like from Amazon. For instance, authentication, authorization, registry. This is one of the requirements that we had. We needed to authenticate the device, the machines one by one, individually, in case one was compromised. Amazon provides that. MQTT, of course. Here's the broker. Device shadows. This was also a requirement for us. We needed to know the last known status. Here it is, provided out of the box. And an API. Also, we needed an API for our apps. Here it is, out of the box as well. The small disadvantage, being picky, is that you're going to have to use a very generic API, and maybe it wouldn't be as reduced as if you would do the API yourself for only your purposes. But anyway, it's documented, because you were all wondering that probably, and it's out of the box ready for us. Some things we don't like. The SDK, well, this is a really small thing, but the SDK used a couple hundred kilobytes, and that was actually too much for our constrained device. So we couldn't really use the SDK. Actually, yeah. So probably in another project, this wouldn't be a problem, but in our case, it was. Then there is the rules engine. Amazon, this is not a problem in itself. This is good, but it's good if you're using other Amazon products. Amazon makes it really, really easy to connect things between Amazon. You can send information, set rules, notifications, everything, queues, but only if you're inside Amazon. And if you're out, you need to do quite more work to connect it to your external part of the platform. Another thing that we didn't like too much is that the applications have to connect using an API, and an API doesn't sound really too real-time, right? Having to do an HTTPS call every time that we need to get the latest tick of information doesn't sound too good as well. So let's analyze the project requirements as we had them. Let's analyze what Amazon is achieving already out of the box. So we got security. It's a secure channel. We got authentication. We got two-way communication. We got good resiliency. Amazon claims they are very good at that, and I think they are. We got the last known status. We got an API. We got a lot of scalability, as much as your wallet can afford. We have proven technologies. Well, proven technologies, Amazon has not been out there for long enough to be called a proven technology, but, I mean, IoT. But there's a full team working on it, so we can be quite sure that the support is not going to be dropped in 1 year or 2 years. So that's why we tick the proven technology, because if they have bugs, they'll fix them. At least we expect. And documentation, most important. So some things that Amazon doesn't provide us. We're not happy with the way that they were giving us the option of real-time data. We don't have obfuscation because the data that we're sending is JSON. That's the format that is used. Lightweight for the small reason that I commented before, that we couldn't put the SDK into our device, but actually because we're using JSON, so we're actually sending more data than we should. I'll go to that later. Rainbows, etc., I didn't mark it, or actually I marked it red, because it will be hard for us to implement new requirements if they do not fit nice into Amazon, because then we'll have to do them ourselves outside. Small tech stack. There are some things that we will not be able to do in that stack, like admin side, debugging, all of that. So what happened? That at the end, we will have to have our own admin side, our own stack of technologies for having that running. And then we will end up having two big pieces of software. The one that is related to Amazon and the other one. So that this is why it cannot be considered like a really small stack. And then the reduced data transfer, if everything has to go through the server one and the other we're using JSON for this, it's not going to be considered like a reduced data transfer. So the conclusion for this is that you can use it, but only if it really matches what you want to do. Otherwise, let's check how to set up our own solution. So the first thing is to get a broker. So we need to get a broker that supports MQTT, and we have like a lot of options, a lot of them. There is every week or 2 weeks probably there pops a new company that has an MQTT server. So I'm just going to show a few ones: ActiveMQ, Mosquito, eMQTT, VernMQ, HiveMQ, CloudMQ, RabbitMQ. So there's not a lot of creativity in the names for these kind of companies. But, I mean, you could choose any that you wanted. Some are you pay them and they are already deployed. The others, you deploy them yourself. But we chose RabbitMQ for going very fast for some reasons. It's been a top player for many years. It has scalability proven, both vertical, of course, and horizontal. It can convert from MQTT to other protocols, which is a goodie. It's not something that we require, but AMQP is something that servers like. There is no payment for use, and we were familiar with it, so this also counted. So that's what we chose this, but probably if you chose any of the others, it would be good as well. Now, we got an extra bonus for doing the broker ourselves, and is that now we can do PubSub, and the mini brew can send the information to RabbitMQ, and the devices, all of them that they want to listen to the actual brewing session, they can be listening to Rabbit. So the information for real time doesn't need to pass through the server anymore. So what is Python doing while the devices get real time data? Chillaxing. There's no need to do anything. Now what? Let's talk to that broker. We got a broker, right? So we'll use Python now, finally. There is a library from Eclipse, and I promised myself I wouldn't show any code because this talk is beginner and also it's very short in time. But now that I already showed it, let me go very fast through it. So it's so easy as you only need to import the MQTT module, and then you just set a few callbacks. On connection, subscribe to a topic. On this connection, on message, do something with that message. You connect to the broker, and voila, you get it. It's so easy to get an MQTT server in Python. So we got one thing fixed. Time to look at the API. In Python, of course. So options. Here, I could go through all of the options, and actually, there would be a lot of fights if we started a discussion. Only discussing this slide could take like a full talk, and only discussing each one of them would take a full talk as well, each one of them. So I'm going to just go very fast and say which one we chose, okay? So Bottle, Django TastyPie, Flask, Falcon, Django REST Framework, and there are even more. Actually, we chose Django REST Framework because of course, we were familiar with it. We already had a part of the API with that. And well, it's scalable. There is loads of documentations of external plugins and apps, and there's everything you may need. You can cache everything. So it's a really good. And now with the latest version that I just got to know a few days ago, there's really good. There are some goodies like automatic documentation and stuff that you should really check out. So that's it. Oh, sorry. Okay, so how are we doing right now after the choices? We got real-time data now. We got security. because through broker you can also connect to SSL. Two-way communication, thanks to MQTT. And we reduce the data transfer by skipping the going through the API. Some things we also got is the last known status because we program it. Now it's our API. We got debugging. We can use debugging, and we can use the admin side to help the staff debug the machines. We got the admin side with Django, of course, and we got the API we mentioned. We also got error tracking, because we are familiar with tracking errors with Python, so that can be considered that it will be easier for us to debug Python than to debug any other stuff. So some other things we already got by using those two is resiliency and scalability, but this depends, of course, on how you do your DevOps, how you're going to deploy. You're going to deploy in clusters, et cetera, et cetera. But it's full of documentation of how to make these systems scalable, because they are very famous technologies. We got rainbows, et cetera. Sorry. We got rainbows, et cetera, because now it's Python and we can do everything we want with it. We all know that, right? And proven technologies, of course, otherwise we wouldn't be in this conference. Small tech stack. Now we got only these two pieces of software and that we really understand. And some things that we still don't have. We don't have obfuscation. The messages are still being sent through JSON. We don't have authentication. Everyone can connect to the broker and just start messing up there. And we cannot say it's lightweight on the device because we just sending messages to MQTT, that's super light. We don't need any library for that. And it's also, but it's not lightweight that we're not sending the small amount of information. We're actually sending more information than needed. And documentation, it's fine, guys. It's full of documentation for these two things. So let's start solving the remaining parts. Authentication in Python as well. There is a really nice plugin for RabbitMQ. It may sound a little bit tricky. Let me explain it. It's a RabbitMQ authentication backend via HTTP. Okay? What does this mean? Now, when the device, when the machine wants to connect to the broker, instead of the broker just saying, yeah, you can connect or you cannot connect, it will pass that information to Python, and Python will check the database and say if that machine can actually connect or not. So then we don't need to have all that in the broker. It can be in our normal database. Nice. And response, and remember, it's a long-lived TCP connection, just once. That's really cool. This works for devices as well. So we checked another one. There's authentication now. So let's go for the last one. Obfuscated and lightweight messages. So how are we going to do this? With Python? No, with Google. So if you don't know protocol buffers yet, you should, if you use any kind of API. It's a protocol from Google that actually, well, this could take also another talk just to explain, but I will try to just go very fast and explain it. But as you see in this example, JSON, that the device could send to the server or to the machine could send to the server or the device, you see there, in each one of these messages, there's going to be a lot of repeated information. You're going to send the ID every time, the ID string. You're going to send the timestamp by string. You're going to send the data, action, sensor 1, sensor 2. This is information that is going to be repeated over and over and over. And that's going to consume data. And that is also going to make it slower. So we don't want that. That's also, it's really easy to read. How are we going to solve this with protocol buffers? Protocol buffers, actually, what it does is that this specification of how the message is built is shared between the parties that are communicating, but it's not transmitted through the wire. So actually, you got the specification on both ends, and you only send the data that is different every time. If anybody from Google was here, probably they would shoot me, because it's not really like this, but this is an example, so you see actually what is being transferred, yeah? This, Google also didn't want to sponsor my talk, I don't know why, but so I'm not going to show you how it works, but this is really easy, you know, just build which fields your message will have, if they are required, optional, so then you can change the requirements, they are always backwards compatible, and then you will not have problem if you're upgrading the message that you sent and somebody is using an old spec. So how are we doing now? Of course, both things checked. We are happy with the solution now. This is a very, very small final architecture, very, very simple. But you can see that we got the web servers, we got the 3 blocks that we talked about, some endpoints for RabbitMQ, an MQTT listener and responder, and then we got the Django API for the devices. And we also got the Rabbit broker for devices and machines, for the web servers, to communicate. And of course, database, cache, and everything that is usually used in a web platform. So everything is scalable because everything is in the cloud. So and everything, all of those technologies are easy to scale. So this is it. This is already it. I was probably my boss is going to watch me on YouTube. So I want to tell you that I work at a really cool company called Elements Interactive. We work at Barcelona in Spain and Almere in the Netherlands. So if you want to do cool projects like this, be sure to enter or just contact me after the talk, and I'll be happy to explain what we do and how we do it. So thank you very much for your attention. You got any questions?
Yeah.
What about unit testing? I hope you're right.
Sorry?
What about unit testing?
Yeah.
I hope you write them, right?
Yeah.
Okay.
We got them.
Actually,
and documentation.
The question is, which test runner are you using?
We are only using the default one, I mean.
Okay.
Yeah.
Is it PyTest or NOS test or?
Right now we're using the test cases, but we were thinking of trying PyTest, but we still didn't do it. So right now we got a very, very good coverage, but on test cases, normal.
How does the beer taste like?
Hi, I have one question. Do you have a hardware embedded security? Because I wonder, what if someone hacks the API and make like and increase the temperature and pressure and make like a remote bomb, essentially?
Or set the mini brew on fire, right?
Yeah.
Actually, the mini brew is also intelligent, and it does a validation of all the recipes, and so there is no way that anything that could break the mini brew is accepted. Actually, if you send a recipe to the mini brew and it finds it's not good, it will just answer that it could not be started, with some information, of course. But yeah, there's no risk for bombs. So if you want to buy it, it's safe.
Any more?
Have you thought about using Thrift instead of Google protocol buffers? If yes, then what's better about protocol buffers? I don't know.
Protocol buffers better than, sorry?
Thrift, Apache Thrift.
I don't know about it.
Okay.
We were pretty happy with protocol buffers because they had everything we needed. The benchmarks were very good. So actually we just found it. This is really cool. Stop here. So actually we didn't try that.
Okay.
But I'll write it down.
Hi, I was just wondering, what kind of data do you send from the mini brew to?
It's well, actually I don't really know exactly because that's more of a hardware thing, but there is like a zillion sensors around all the mini brew, pressure, if there is water flowing around, which is the current status, if there is actions pending from the user, what is the next thing that it's going to do. I mean, there's a lot of information. Actually, the JSON I just showed, it was like a ridiculous example because it's actually much bigger. So yeah, that's.
Have you tested what the scalability limit of your stack is? Have you tried to topple the thing?
No, not yet, not the top. We're actually working with Minibrew sending, like, if I don't remember wrong, it's sending each Minibrew that we're testing. There are quite some of them, quite some PCBs testing at the same time. And each one is sending like 60 times more information that it will send in the real world, because we're really logging everything into very detailed. So right now we can handle already with a really small cloud architecture, and I mean really small, we can handle like hundreds of mini brews already. So when we just make a normal production deployment, it's going to be able to handle thousands, and of course we're going to implement scalability, clustering, and everything.
Okay. Thank you all for coming. Thanks, Chesco. Stay tuned for keeping your lights on. Is that you, Scott? Hi. Welcome all to using Python to keep the lights on. Give Scott some clapping.
Thanks. So this talk is really about, well, I guess it's more of a celebration. The last talk was excellent about the architecture and such like. I guess this is a compliment in that we talk very little about the architecture, but it's more about talking about the problem that we're solving and why we like using Python so much to solve it. So I'm the technical director at LimeJump. We've been going as a company proper for a couple of years. Let's get this next slide. So LimeJump is a utility in the UK. We're able to trade energy, and the thing that we're interested today in is aggregation services. We're going to talk a bit more about that in a minute. But we work with small companies in association with the National Grid. So the National Grid in the UK own the high voltage electricity network. just for England and Wales. And they work to maintain that, and also they try to keep supply and demand of electricity balanced, and that's kind of where we come in. So, if we go back to 1870 or 1933 in the UK, when our first national power network was created, you had big, mostly coal-powered power stations that created a large amount of power, which was then distributed through high voltage lines across the country, going into lower voltage lines, eventually down to big factories, smaller factories, and consumers. Now, that worked well back in 1870 and 1930s, but things are changing now. We've got concerns about climate, so we don't want to have big coal-fired power stations, or other big stations for that matter. And there are new types of power generation coming in, like wind, solar generation. We've got some wave power, and other things like aerobic digestion, where you use waste food products and animal manure to generate gas, which can then power engines which produce electricity. And we've got landfill gas, which is methane coming off waste to produce electricity again. And just now, things like batteries are coming in. So the power network has to change to meet these new challenges. So this is the kind of thing that we're starting to see. So we're getting a much more distributed power system. So you can see some solar panels and some aerobic digestion there, and all sorts of different ways of producing power. And they're working on a much smaller scale. The amount of electricity they generate is smaller. They don't come down these high voltage lines so much as more local systems. So we need to start controlling them more locally to balance the grid. But really, what do I mean by balancing the grid? So, if you think back to the original power stations, you had a big coal fire, boiling water up, turning it through turbines. That would turn a huge shaft, and then if you go back to your magnetic field theory, if you turn a shaft in magnetic field, you can generate electricity. And the speed of that shaft is proportional to the frequency of the AC current you get out. So what we're trying to do is to keep this shaft moving at a constant velocity so we get 50 hertz out. So what we have to think is, if there's too much load on this shaft, say you've got too many lights on, or for example a power station is broken down, then this shaft is going to start slowing down because there's not enough power to push it. The frequency of electricity will go down. And vice versa, if it's the middle of the night and no one's really using electricity, and suddenly the wind starts blowing very strongly in Scotland, as happens sometimes, you get too much wind power, so there's more supply than demand, and the frequency starts to go up. So that's kind of summarized here. So when supply is equal to demand, which is where we want to be, everything is at 50 hertz, and then as supply is outstripped by demand, the frequency goes down. And when supply is higher than demand, then the frequency goes up. And really, what we're trying to do is to keep it within 49.5 and 50.5. In reality, we keep it in a much tighter band than that. But when we start getting to these points, then we start having problems. Electronic equipment will stop working in some cases. And if things get really bad, you'll get a complete blackout, and that's really not what we want. So that's where we come in. So as I said earlier, the National Grid's job is to balance supply and demand. So they have products which we work with customers. So we work with lots of small customers who aren't big enough to go to the National Grid directly. So we coordinate their response and then sell them as a group together to deliver different products to the National Grid. The one we've been working on for the last year, or we've been starting to implement for the last year with customers, is a static response. So when things are getting quite bad, so when frequency goes down to 49.7 or up to 50.3, we either get customers who produce electricity to turn things on if the frequency's gone low, or if they use electricity, we get them to turn things off. And vice versa, when the frequency of the grid goes too high, we get people who produce electricity to turn their production down, or customers who use electricity to turn their usage of electricity up. I'm going to touch upon this a lot more and how we do that. But then also in the future, we're going to be starting to look at things like dynamic products where we track the grid frequency, so we keep it in a much tighter band, and you get 2 seconds to respond to a change in grid frequency. And then enhanced frequency response, which is responding very quickly, and that's coming out in the future in the next 1 to 2 years. And there you have to respond to a change in grid frequency within 1 second. So the only thing capable of doing that at the moment is to have a big battery and to turn the power output from the battery up and down. So what exactly do we do, and where does Python come in? Well, because we're working with lots of small customers, we have to go and install a panel on each of their sites. So this sits with generators or with factory equipment. And we have a PLC in there, a programmable logic controller, which is industrial computer, effectively, that you can use for automation tasks. We have data being back for a 3G modem. We have a quad-core, it's a Raspberry Pi type device where all our Python sits at a customer site level. And also we're starting to use things like Arduinos to control and measure customer equipment. And also we have power meters which sit on the power lines out of equipment so that we can measure what's going on, or how much electricity they're producing. And we do this, we monitor power every second, so we can see second by second how much power a customer is producing or using. We measure frequency on site, so we know what's happening in terms of frequency on site 10 times a second. And we also measure what our system is doing 10 times a second, so we can keep a track of whether everything's performing properly. Now, for those of you in the last talk, this is a very similar architecture to the one being discussed in the last talk. I'm not going to talk about it quite so much, other than to say that the data logger there is pure Python, and everything to the right of it is also pretty much Python except the front-end stuff. And everything to the left of the data logger, so the sub-meter controllers and PLCs, they're in a mixture of C and PLC code, which I'll show in a second, which is some ladder logic and some programming by diagram, really. And then we've got industrial power meters, which we communicate through a protocol called Modbus from the 1970s. So we've got those connected to assets, and we can also control assets from there. I should also point out the data logger doesn't just log data, it also sets up the PLC so we can have a semi-autonomous response to events. So the PLC is the part that responds when frequency goes out of the spec that I was talking about earlier, and it's also the PLC that controls the output of an asset if we were to want to do dynamic or enhanced frequency response. So that's kind of how we do things. Why do we use Python? Well, it's fast to develop. This has been developed within 2 years, really. I think we've written virtually everything that's in production now within the last 2 years, which I come from a C and C++ background. I don't think we could have done this if we'd used C. There's a huge selection of free libraries. I'm preaching to the converted, I guess, with this, but it's transformed the way that we can do things, especially with things like Modbus. And the testing, I'm a big fan of PyTest, so we use PyTest in all our testing. And I should say, lastly, we use Python, so I can come to Europython each year. So, where have we been having problems with Python? That's a good question. We haven't been having massive problems with Python. We've been moving to async I/O recently, and we've cut down our load on our embedded processors, the processors at the customer sites, by 5-10-fold by using async I/O. So that's been really great. We think it's not quite as elegant as it could be, but that seems to be changing a lot with each new version of Python, so we're really enjoying using that. But I guess the biggest problem we have is finding good Python developers in London, which I'm sure lots of people can sympathize with. So that's kind of really our problems or things that we've been using. Where would we like to use Python? Well, as I said before, I like to talk yesterday on the micro bit and starting to use Python in microprocessors. The diagram on the right is part of the PLC software that I was talking about earlier. I've spent days and days with our PLC suppliers debugging this software. It's tricky. It's very, very tricky. This is the kind of code you get. You can't put test harnesses around it very easily, so you end up having to try and create every single situation by a mixture of forcing variables within the program and creating the conditions with I/O and hardware to try and test that it's going to respond how you want it to respond in each way. So if anyone has any ideas for getting us out of using PLCs, then I'd be really, really pleased to hear them, especially if it's using Python. I'd also say we've been using embedded controls with C, but again, that's not quite as nice, in my opinion anyway. So, what are we going to do next? This is a test case from last week. I spoke about dynamic frequency response. So, if you look at the second graph down, you'll see this is a test profile we've injected into one of our panels. This is at a battery site, so this is a big solar panel array with a 800 kilowatt battery attached to it. So the battery is charged up by the solar array during the day, and then we can discharge it when the customer can get the best prices for the electricity. So what we've done here is we've got a charged system. I should say SOC stands for state of charge. So 140 actually means 70% charge because there's two battery systems attached. So what we've done is inject different frequencies into that, and if you look at the top one, the kilowatt out, so that's the kilowatt output of the battery, mirrors the frequency. So as frequency goes down, the output of the battery goes up and tracks pretty much the frequency as it goes up and down, and you can see the battery discharges and then charges again as we use the power in different ways. So once we've done that, our next job is going to be delivering dynamic response, and, which I haven't mentioned now, this is response at a local level, so this is just a battery responding to the grid. What we're looking to do next as well is to have a response across several pieces of equipment, so we might have an engine and a battery, maybe solar farms as well, and what we're looking to do is have each one of them produce their own individual response, which when summed together creates this kind of group response. This means that a lot more customers can get involved in this program, and we can give a larger lump of responsive power to the national grid, so it kind of helps everyone. And let's do some more Python as well. And that's it.
Who has any questions?
Thanks for the talk. At what kind of scale is this running? How many of these devices are running?
So we had our first site installs last year. We're now in the tens of installs. Probably by the end of the year, we'll be moving up to hundreds of installs and on from there. In terms of power, sites range from about 100 kilowatt for small sites up to a couple of megawatts for big sites. So if you compare that with a power station might be 1,300 megawatts. So we're rising very quickly. So it is getting bigger and bigger.
Yeah. I'm not sure if I understood this correctly from what you said earlier, but is it the case that when demand falls so much that the frequency is at risk of rising, or demand rises and the frequency is at risk of falling, that you will get large users of electricity to use more or less?
Yeah, that's right.
And is there a possibility of doing this? Not, I guess you can do that very easily with huge users, but with embedded systems in all kinds of devices in people's homes, you could presumably get ordinary things like fridges and heating systems and so on to use more or less appropriately. Is that a possibility?
Yeah. So we've started at the industrial scale because it's easier to have a viable business at that scale. But as we refine our technology, we can move into smaller and smaller producers. So in the end, hopefully, yes, we'll be able to use home supplies. So if you think of a fridge, for instance, a fridge is only on some of the time. But if you had 1,000 fridges, you could predict the base load that the aggregated 1,000 fridges use. So yeah, that's definitely what we're aiming towards.
How much was security a consideration? Because I could imagine if these systems are hacked, you could destabilize the power grid pretty easily.
Yes, security is a big consideration, yeah. So yeah, we can turn on and off these big batteries and engines. So yeah, that is something we think about a lot. Yeah, I don't want to talk about that bit too much though. Yeah.
So is it the case that when the frequency drops, you respond, but what happens if you respond and somebody else responds and somebody else responds? Isn't there a risk? How do you not like yo-yo?
That is very true, actually, and has happened. So we're all employed by the National Grid, so they know how much the response will be. So they contract out a set response. But you're right, it has been seen on a few occasions where everyone responds at once and you go from having low frequency to having high frequency. So yeah, that's one for the National Grid to sort out, luckily. But that's why they're moving to the dynamic responses, because of course they're much more granular, so they correct things much more quickly, so you don't get that yo-yoing. I should probably also mention that when we're moving away from these big rotating shaft type systems, the power generation, the coal-fired power stations, we're losing a lot of inertia in the system, which is a stabilizing effect. So a big shaft turning acts like a flywheel, whereas with things like wind, they don't have a flywheel as such because they're electronic inverters. So yeah, as the UK reduces that, we're going to become more unstable. So we have to be more careful to stop this swinging up and down of frequency.
Any more questions? Great.
Yeah, I'll answer questions if anyone wants afterwards, or yeah.
Cool. Yeah. Lightning talks on A1, and enjoy your extended break.